Good morning, students. Now, the next topic is maxima and minima of the function of two variables. Right here, some description is given to you. No need to by heart this description. Only the thing is stationary points and extreme points. These are the definitions. A point is said to be a stationary point if the first order partial derivatives vanish at that point. That means suppose one function is given to you f of x comma y. Now we have to find the first order partial derivatives. That means dou f by dou x we have to find out, dou f by dou y we have to find out. If dou f by dou x is equal to 0 at a given point, then that point is said to be a stationary point. And dou f by dou y at the given point is equal to 0, that point is said to be a stationary point. Right? Now, see, next one is very important topic is Lagrange's condition for maxima and minima values of a function of two variables. This is very important concept. Now see here, now we have to by heart these values. Dou square f by dou x square is denoted by r, dou square f by dou y square is denoted by t, dou square f by dou x dou y is denoted by s. You need to find r, t, s values by finding second order partial derivatives. After getting these values at a given point means a comma b, at x is equal to a and at y is equal to b. Right? After finding the second order partial derivatives, and that means RTS, we need to calculate RT minus s square. If RT minus s square is greater than 0 and also r greater than 0, right? R value at a given point, if that value is greater than 0 and RT minus s square is also greater than 0, then the function has minimum. If a function has minimum value at that point, if RT minus s square is greater than 0 and r is less than 0, then the function has maximum value at the given point. Right? If RT minus s square is less than 0, then there is neither a maximum nor a minimum value. If RT minus s square is less than 0, that means a negative value, then the function has neither a maximum nor a minimum value. Suppose next condition, if RT minus s square is equal to 0, then the maximum or minimum value of a function will depend on the sign of r. Right? These are the conditions. These two are very important conditions. RT minus s square greater than 0 and r greater than 0. Then r has the function has minimum value. RT minus s square is greater than 0 and r is less than 0. Then the function has a minimum value. See, now we are going to discuss these problems. Now discuss the maximum or minimum values of u, where u is equal to this one, and second problem is this one. Second problem is a homework for you. Given that u is equal to x cube plus y cube minus 3axy, call that equation number 1. Now differentiate equation 1 with respect to x partially. Sir, why sir? To find the maxima and minima, we have to find r, t, s, no? That means dou square f by dou x square we have to find out, dou square f by dou y square also we have to find out, dou square f by dou x dou y, right? Now that for that to find those values, first of all we need to find first order partial derivatives. Now dou u, here the given function is u, that's why I'm writing u. Right? If the given function is denoted by f, then I'll write f. Right? Dou u by dou x is equal to partial derivative with respect to x. The x derivative of x cube is 3x square, derivative of y cube is 0, minus 3axy. 3ay is constant, derivative of x is 1 with respect to x. Now I got 3x square minus 3ay. On simplification, dou u by dou x is equal to 3x square minus 3ay. Now differentiate equation 1 with respect to y partially. Dou u by dou y is equal to dou by dou y of x cube plus y cube minus 3axy. Similarly, what will get? Dou u by dou y is equal to 3y square minus 3ax. Now here the point is not given at the initial stage, right? We need to find the maxima or a minima of a function at a point అని చెప్పాం కదా. Now if the point is not given, therefore to find those points we have to equate first order partial derivatives to 0. right? Those are called stationary points అన్నాం కదా, right? Now to get the maxima and minima, we have to equate dou u by dou x to 0, dou u by dou y to 0. Now 3x square minus 3y is equal to 0, 3y square minus 3ax is equal to 0. We have to solve these two equations, right? Solving means we need to find x value and y value, right? X is equal, from the equation 1, x is equal to what? Second equation, x is equal to what? Y square by a, from the second equation. See from here, y square is equal to ax, x is equal to y square by a. Now substitute this x value in the first equation. Now I got y value. Here I am taking LCM, right? After LCM taking y common, y into y cube minus a cube is equal to 0. There are two factors are there. I have to equate each factor to 0. Y is equal to 0, y cube minus a cube is equal to 0. Y is equal to 0, y is equal to a cube. Taking cube root on both sides, I am getting y is equal to a. For y is equal to 0, what is the x value? If you substitute here, 0 only. For y is equal to a, if you substitute here, what you will get? Plus or minus a, right? Or in the first equation, whatever it may be, right? Now therefore the points are what? 0 comma a and a comma a. These are the points. Since x is equal to 0, y is equal to 0, x is equal to a, y is equal to a. Now we need to find RTS. No, for that we have to differentiate once again with respect to x. No, now if you differentiate with respect to x, what I am getting? Dou square u by dou x square can be written as dou u by dou x is equal to dou by dou x of 3x square minus 3ay. Now differentiation, 3x square is 6x, differentiation of this one is 0. Therefore dou square u by dou x square value is 6x. Again differentiating equation 3 with respect to y partially, dou by dou y of dou u by dou y is equal to dou by dou y of 3y square minus 3ax. Again differentiation with respect to y, that you will get 6y. Differentiation of second term is 0, right? Now differentiate equation 2 with respect to y partially in dou by dou y of dou u by dou x. Dou by dou y of dou u by dou x is 3x square minus 3ay. Now if you differentiate with respect to y, this becomes 0 first term. Second term is minus 3a into 1 minus 3a. We know that dou square u by dou x dou y is equal to dou square u by dou y dou x. Both are same. Okay, now see, let r is equal to what? Dou square u by dou x square is equal to 6x. S is equal to dou square u by dou x dou y is equal to minus 3a. T is equal to dou square u by dou y square, that is 6y. At these points we have to find out. Now see, at 0 x is equal to 0, y is equal to 0. That means at the point 0 comma 0, r value is what? What is r value here? Dou square u by dou x square at 0 comma 0. Sorry, is 6 into 0, got 0. S is equal to dou square u by dou x dou y at 0 comma 0 minus 3a only. T is equal to dou square u by dou y square at the point 0 comma 0 is equal to again 0. Now consider rt minus s square. rt minus r is 0, t is 0, minus s is minus 3a whole square. Now I got minus 9a square, which is less than 0. Since rt minus a square is s square is less than 0, there is no maximum minimum, right? At the point x is equal to 0, y is equal to 0. Just now what is the condition? See, star button kada. If rt minus s square is less than 0, then there is neither maximum nor minimum value of the given function. See, at this point rt minus s square is less than 0, therefore the function has neither maximum nor minimum at that point only. Now next point is at the point a comma a, x is equal to a, y is equal to a. Again we need to calculate r value at the point a comma a. I got 6a. S value at the point a comma a is minus 3a only, because there is no x, there is no y in this one, right? Now t is equal to 6a. Again consider rt minus s square. Rt minus s square is equal to r is value 6a into t is 6a minus 3a whole square. 36a square minus 9a square. This is positive. Again positive into negative is negative. 27a square. Now whatever it may be the a value, here a may be negative, a may be positive, right? For negative or positive, a square becomes positive only. Therefore this entire thing is greater than 0. 27 is greater than 0 and a square is also greater than 0 for all a means maybe for all values negative or positive, that value is always greater than 0. Here rt minus s square is greater than 0. If a greater than 0, just I am writing. Now r is equal to 6a greater than 0. If a is less than 0, r is 6a, that means less than 0. For negative values of r, a, this r value is negative, right? Here it is positive because it is a square, no, right? Now there are two cases are there, no, right? If r is greater than 0, that means if a is less than a is greater than 0, r value is greater than 0. Here a greater than 0, r is greater than 0. At this point the given function has minimum value. If a is less than 0, then this r is less than 0, right? Here rt minus s is greater than 0 and r is less than 0. At this case, at this point, at this juncture, the given function u has maximum value. See, sorry. Now see your conclusion. If a is less than 0, then u has maximum value at this point, right? If a is greater than 0, then u has minimum value at this point. If a is greater than means obviously r is greater than 0, right? R is greater than 0, rt minus s square greater than 0, both are greater than 0. That's why this u has a minimum value. If a is less than 0, just now you wrote that condition, no? If a is less than 0, then r is also less than 0. Rt minus s square is greater than 0. Therefore, rt minus s square is greater than 0 and r is less than 0. Therefore, this u has maximum value at a comma a whenever a is less than 0. That is the point. Now, again, this one is a homework for you as it is simple one. Next one, discuss the maximum value of u where u is given like this. Now same procedure. First of all, what we have to do, we have to write down the given equation. After writing the given equation, we have to find first order partial derivatives, that is dou f by dou x we have to find out, dou f by dou y also, right? Now here dou u by dou x I am finding, dou u by dou y, right, with respect to x. After finding the first order partial derivatives, right, now we need to find a stationary point, right? Now first of all, here only I am finding dou square u by dou x square, and r value I got minus 6ay plus 6xy, and differentiate equation 2 with respect to y partially, dou square u by dou y dou x is equal to this one, this is called s, and with respect to y, dou square u by dou y square also we got rst. Now to find maxima and minima, what we have to do, we have to equate first order partial derivatives to 0. See here, for maxima or minima of u, dou u by dou x is equal to 0 and dou u by dou y is equal to 0, right? It's a very lengthy problem. Now we are writing dou u by dou x value is equal to 0. Now I am simplifying this one. First of all, y into something, right? Y is equal to 0 and again this factor is equal to 0. Dou u by dou y is equal to 0. Now again, there are two cases now. I have to solve this one and this one, right? Now here there are two equations I got, y is equal to 0, substitute y is equal to 0 in this equation. I got x values as x is equal to 0, x is equal to a, x is equal to 2a, right? Now see, the values of x and y are x is equal to 0, y is equal to 0, right? Whenever y is equal to 0, I got three values for x. Now I am writing the pairs. X is equal to a when y is equal to 0. X is equal to 2a when y is equal to 0. Now I got 3 points of 0 comma 0, a comma 0, 2a comma 0. Again I have to solve this equation also. No, I am using this part. Now I have to use this part also. From equation 4, solving equation 4 and equation 5. Now again by multiplying equation by x we get this one, and subtracting equation 6 and 5. Now on simplification, I am getting x square minus y square into 3a minus 2x. On solving this one, x is equal to plus or minus y, x is equal to 2a by 2. Substitute x is equal to y in equation number 4. Again I got y value a comma a by 2, x is equal to a comma a by 2. Why? Because x is equal to y. No, y is equal to a, then also x is equal to a. When y is equal to a by 2, x is also equal to a by 2. Now similarly put x is equal to minus y. Y's are because x is equal to plus or minus y. No, now whenever y is positive I am getting this one, whenever y is negative again I have to find the x values. See, y value is minus a and y value is minus a by 2. When y is equal to minus a, x becomes plus a. When a is equal to minus a by 2, x becomes a by 2. Now we have to write down the pairs, all the pairs. First 0 comma 0, a comma 0, 2a comma 0, a comma a by 2 comma a by 2, a comma minus a by 2 comma minus a by 2, 3a by 2 comma a by 2, 3a by 2 comma minus a by 2. These values at these points, in each case you have to find, we have to find rt minus s square. It's very lengthy problem, right? Now see, at the point a comma a, right? At the point a comma a, now I am substituting in r, right? A is equal, x is equal to a, y is equal to a. I got this value 0. Similarly s is equal to 2a square, t is equal to 0. Now I need to find rt minus s square. Rt minus s square is negative. If rt minus s square is less than 0, then u has neither maximum nor minimum at the point a comma a. No need to compare with r. If it is positive only, then we have to compare with r. If it is less than 0, then u has neither maximum or minimum. Now at the point a comma minus a, again if you substitute in this one, r is equal to 0, t is equal to 0, s is equal to 2a square. Rt minus s square is less than 0 at this point also. U has neither maximum nor minimum at this point. Now at 3a by 2 comma a by 2, again r value I have to substitute. In the place of x 3a by 2, in the place of y a by 2 I have to substitute, right? R value is 3a square by 2, s value at this point is a square by 2, t value at this point is equal to 3a square by 2. Again we have to calculate rt minus s square. Rt minus s square is 2a power 4, which is greater than 0. Rt minus s square is greater than 0 at this point. Then what about r? R value is also greater than 0. See here, r is 3a square by 2. A is whatever it may be the a value, whether it is positive or negative, it is always greater than 0 because it is square, right? Therefore at this point 3a by 2, a by 2, u has a minimum value at this point, right? Now again similarly at a by 2 minus a by 2, you have to calculate rt minus s square, right? So these are the conditions, right? We'll discuss next problem in the next class. This is show that the distance of any point xyz on the plane from the origin is given by L is equal to something. Hence find the point on the plane that is nearest to the origin. Okay. Now this maxima and minima, this topic is very important. It will come in the examination, main examination. Now అది మీరు హోంవర్క్ ప్రాబ్లం ఉందా కంపల్సరీ ప్రాక్టీస్ చేయండి అమ్మ. ఇట్స్ వెరీ లెంతీ ప్రాబ్లమ్స్ మ్యాక్సిమా అండ్ మినిమా. సో కొంచెం పేషెన్స్తో నీట్గా చేయండి.